So when we call os.exit, you can just assume that from that point on, it's like somebody just walked away and whatever happens, happens, but it's all tumbling down at some point.
Yes. It's a very, very hard exit.
That's actually the only way you can return an exit code that's non-zero, isn't it?
Right.
That's interesting then. So you have to be careful with that. But you may well want your program to exit with a specific status code. But if you're doing that deep somewhere in your program, it's possible other things aren't happening. So you probably would only want to use OS exit right at the top in the main or near there, wouldn't you? Based on probably the return from some other functions that you're creating as part of your application.
Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. What's up, Gophers? Our friends over Gravitational made a big transition at the end of 2020 to rebrand as Teleport and shared a new product announcement to showcase the direction they're taking. Teleport is operating from a vision of being able to run and access software anywhere in a secure and compliant manner, something they call environment-free computing. With Teleport, engineering teams can quickly access any resource anywhere using a unified access plane that consolidates access controls and auditing across all environments, infrastructure, applications, as well as data. Teleport server access lets you SSH securely into Linux servers and smart devices with a complete audit trail. Teleport Kubernetes access lets you access Kubernetes clusters securely with complete visibility to access and behavior. And finally, Teleport application access lets you access web apps running behind NAT and firewalls with security and compliance. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Remember that Raspberry Pi 400 that Mark Bates won on our Go Panic episode? He ended up declining the prize because, quote, I'm allergic to raspberries. So we're going to give it away instead to one lucky listener, and we'll announce that giveaway soon on Twitter. Follow at GoTimeFM right now so you don't miss it. Okay, let's get this program started. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer. Today we're talking about what happens when Go programs end. What happens when the func main returns? What happens to Go routines that might already still be running? Or you remember those deferred statements? Where have they? What's happening with them? Are they going to go? What about open files? Do they get closed for me, or do I have to do that? And what about those HTTP response bodies? We're supposed to be closing them. I hope everyone's been remembering to close response bodies. But what happens to those when you exit? Well, there's loads of questions, and we're going to find out the answer to all of them on this deep dive forensic analysis breakdown edition. Super cool, where we look at what happens when Go programs end. So yeah, a very dramatic intro for what could be a very mundane subject, but I don't think it's going to be. Joining me today to discuss this, it's regular John Calhoun. Hello, John.
Hey, Matt.
You told me earlier you've never had a Go program end. So this is
I didn't
uncharted.
say that.
No, what
I
did
said
you say?
most of my programs aren't designed to end. So when they
Right.
end, what happens is I'm trying to make sure my server gets it back up.
Right. So interesting. So, okay, well, I'm sure we'll talk more about that. We're also joined by a member of the Go team who's been working on the runtime for the last 2.3 years, he told me. Welcome to the show, Michael Knyszek. Hello.
Hello.
Welcome.
Thank you. Excited to be here.
Okay, good. Is that real, or is he just being polite, showbiz polite?
I am nervous, but also excited.
Okay,
I'm
same.
both.
They're similar, aren't they? They're similar things. Okay, well, let's start for maybe right at the beginning then, for someone new to Go. What happens? I mean, ultimately, a program at the end will stop running. So what happens there? What's going on?
Well, I guess basically the Go itself is just going to this is going to come out the wrong way. Hopefully we'll dive deeper and explain why and what, but Go kind of just leaves a mess behind and calls directly into the operating system, just like, we're done with everything. And everything dies and gets cleaned up, and the operating system goes and cleans everything up. And if that, running Go program had a parent process, on Linux, all processes have parents, then it returns it gives that processor, that parent, a return code. On Linux, it's, I believe, usually some value between 0 and 255. For compatibility reasons, Go os. I won't get into os.exit yet, but basically Go by default returns 0, which means all good. Returning anything non-zero effectively means something went wrong. Some programs like to use a different number for different meanings of something went wrong, but generally that's the pattern. Just everything went fine and something went wrong.
Okay, great. And are they like HTTP status codes, those exit codes? Are there any standards, or is it just that 0 means it was success, everything else is then defined by the program?
I think that's the only thing you can actually rely on. If you're dealing with a specific program, like you're writing like a wrapper script for it and you want to have like maybe another error message come out or log that somewhere, then it can be useful. I feel like I know a few programs that like define in like a big table like what all the different values mean, but I think in general the only thing you can rely on is 0 and non-zero.
Right. So in Go, a main function, when that returns, there's no return argument, so it just returns by falling out the back of the block. That will just by default return as 0 then, would it?
That's correct, yeah.
And then if you do want to return something non-zero, that's when we need to look at OS exit.
Yes, precisely.
Okay, well, we'll get into that later. But you mentioned that everything gets cleaned up by the operating system and Go kind of leaves a mess. What things get cleaned up specifically there?
Basically, Go asks the operating system for a bunch of memory. So the most obvious thing is all that memory gets collected. So basically all of the memory-related resources that the OS has given the application get reclaimed. Other things include if there are any open file handles. And so this extends quite broadly. But in the simple case, you just have like a file on your local hard disk or something like what you usually think of as a file. Basically, the OS will close that file handle for you. It keeps track of all of them. And once your program exits, it goes over all of them and just says, okay, this process is no longer using this file.
So that's cool then. So the memory, reclaiming the memory is nice. So then if we've got some program that has a massive map of data, before we return, we don't have to go through and delete all that data, do we? We don't have to go and do that sort of cleaning up, releasing memory. That will just happen automatically, right? Yeah. And then the files one's an interesting one. If you open a file in Go, and normally we defer the close of that file, or you might have some other mechanism for closing that. If you don't close that file and the program exits, does that leak a file handle, or does the operating system clean that up?
No, the operating system cleans that up. So files on most systems are like the concept of a file goes pretty deep into the OS. So it actually does keep track of these things and does say like, okay, this process exited, and usually keeps like a reference count for these files, if I recall. I'm a little bit rusty on this part. And it goes and decrements that reference count.
Right.
But basically, it does the equivalent of closing any open files you have.
Mm-hmm. Right, of course. So if you've got that code in a loop or something, then it's important to remember to close files as you go. You can't rely on that program ending thing. Yeah. Yeah, very cool. John, how do you normally exit and deal with cancellation and things in your programs? If you write a command line tool, how would you do it?
I mean, the most common way you see is, wrap or using context and sort of handling it that way. But I can definitely say I'm guilty of not doing that all the time, especially when it's, if I'm writing something, just a quick tool for myself or whatever, and I don't expect it to take very long. If it's only going to grab 3 files, parse them real quick, do something and be done. Usually if I wanted to cancel it, the program would be done before it ended anyway, so it really doesn't make much of a difference. Now, if I had something more long running, then maybe it makes more sense. I guess it kind of depends on what you're doing and whether or not stopping in the middle of something is actually really bad or not. So that's kind of like the determining factor for me is does it actually matter if it just stops?
Yeah, so that's interesting. Does it matter if this program just stops? And you can imagine programs, and I've written one recently that was processing files, and it would open another file to generate some data basically from the first file. So it would create a new file for each file that it found. And it was kind of, because it was a small hacky thing, it was relying on the existence of that file for state to see whether it had been processed or not. So in this case, if the program just ended halfway or in the middle of all that somewhere, I could end up in a state on disk that wasn't desirable and didn't reflect the reality of it. So that leads us kind of into this sort of talking about a graceful shutdown as well, where we notice that a program wants to end, or the operating system or somebody wants to end this program, but we've got some work to do before. So what are our options for doing something like that? How do we know that the program's going to end, and how can we then do some work before?
So programs can really end, broadly speaking, can end in two ways. Either something tells the program to end, or it decides I'm done and closes itself out, right? So in the context of something external, you might see something like Control-C. So if you type Control-C in your command line, then what basically happens is Linux sends what's called a signal, which are surprisingly difficult to work with correctly outside of Go. Go actually makes this quite nice to use because it wraps the whole thing in a channel. But you send, once your program receives a signal, it needs to handle it in some way. And so with Go, you can use the OS signal package to get notified about when you get something like Control-C. Something wants to end your program. And so using the OS signal package lets you capture that and say, okay, let me do the cleanup that I need to do so that I can get my graceful shutdown. Internally, there's sort of more, if the program wants to end internally, there's sort of more of an assumption that the program as a whole would know that. And if it wants to gracefully shut down, then it has to provide its own mechanism for doing so.
Right. That makes sense. So is that quite messy in the runtime code there? Because I imagine there's lots of edge cases that it's dealing with and lots of different operating systems, right?
Well, signal handling is notoriously difficult because a signal handler can run just about any time on any thread, which means that a signal can land where you're right in the middle of holding several locks and you're like, okay, is it safe to do anything? Yeah, that part of the runtime is actually quite tricky and difficult to get right. And it's also a complicated part of the OS too. Austin on the Go team found a bug in the Linux kernel related to signals in the Go 1.14 release cycle. So it's tough.
Mm. Yeah, it's quite old. It's old tech, really, isn't it? Because it's really core. So it's really deep somehow in amongst this. Yeah.
But the signal package does really give you a very nice wrapper around this. It's very safe, much easier to use than a regular signal handler.
So let's say I'm jumping into this and I want to figure out how to capture signals. Do I have to learn about a bunch of different signals? Like if somebody's using kill in the Linux terminal to drop a process versus Control-C versus a bunch of different ways you can try to stop a program? Or is this kind of, you pick one or two signals and can go from them? Where does somebody start if they want to get started with this?
I think the OS signal package documentation does describe the different signals pretty well. It's funny you mentioned kill because if I recall correctly, kill is one of those signals that you just simply can't catch. That's what's kind of dangerous about kill is that if you send kill to a process, it never gets the opportunity to clean up. It's like a force quit, right? There's no opportunity. The other two that I'm aware of are sigint, so that's interrupt, that's Control-C, and sigabort is kind of interesting because that will cause the Go runtime to actually dump a bunch of goroutine stack traces. But sigabort is another one that is sometimes useful to handle explicitly, but Control-C is the big one. I do think the OS signal package provides some pretty good documentation on this because it's also wrapping around the fact that you have lots of different, Go supports lots of different platforms, and of course this is going to work slightly differently on Windows and stuff. So I defer to the OS signal documentation for precise semantics.
Fair enough. And since Go 1.16, we actually also have a notify context helper too in the signal package, which will cancel a context on a signal. So that's kind of like nice. So if you're using context for cancellation across your program, and this is essentially the pattern for anyone unfamiliar, where you pass in a context argument as the first argument through the chain of all your programs, and then whenever you've got loops within that of work, or maybe you're iterating over a set of data, you can just periodically, i.e. at the start of each loop, check to see if that context is finished, and there's either a channel that'll be closed, or you can check to see if there's an error being returned. And then you can abort that operation. So that's a nice way to do kind of graceful shutdown, or at least you'll finish what I'm currently doing, and then I'll stop. Gives you that sort of graceful shutdown. You can do that quite nicely with context. But you used to have to write that signal code yourself. And with the addition of notify context, you don't need to anymore. You can just wire it up to a context, and it will be cancelled for you when the program's interrupted. And I think it's good practice. This is something I always do. If you get a second interrupt signal, then it's worth doing a more serious exit. I mean, sometimes I think operating systems will send a kill as the second signal, but if it's just a command line and you press Control-C and something's wrong in your logic somewhere, you can easily hang because you've caught that signal. So it can be good practice to look for a second one and just do an immediate OS exit. And that way you never get caught having to go and try and force quit your own business. Yeah, so that's kind of graceful shutdown, I think, is very cool. Another way to get a kind of form of graceful shutdown, or at least of cleaning up after you, is with the defer statement. So in the func main function, when you defer things in there, they do get called before the function exits, and therefore before the program exits. But that's not true for OS exit, is it, Michael?
No. So OS exit is a hard exit. It basically does the minimal amount of cleanup necessary, which basically for the Go runtime just means if you're running with a race detector enabled, it'll do some cleanup with the race detector. So try to signal that, like, oh, if you have a racy program, it's going to make sure its exit code is non-zero, for instance. But otherwise, yeah, it basically just does a hard exit. It doesn't bother trying to run deferred functions. It also doesn't bother trying to run finalizers, if you're aware of those. Kind of a dark corner of it, but worth mentioning.
Yes. Okay. So OS exit is a very immediate stop, and you're not going to have the nice things that Go would give you. So you do have to bear that in mind. Another thing that's quite interesting is what happens to the standard in and out streams and standard error. For example, does standard out receive an IO EOF at the end of it? Does it do something to close the pipe? What's actually going on there? Is that operating system dependent too?
This might be somewhat system dependent. I'm thinking more in terms of the like Linux, Unix sort of philosophy where pipes are just files. Like to the operating system, it's like it uses the same sort of resource as file handle, right? And these standard out, standard error, standard in all get closed in exactly the same way as any other file. I will note that the moment you do this sort of exit call, whether or not code runs is sort of completely up in the air, right? Some Go code may run in that, few milliseconds before the process gets taken down, or the rather its thread stops. But you can't rely on that, right? So there's no EOF propagated through because it doesn't even there's no code to even process that IO.EOF, if that makes sense. Like the code is not guaranteed to run at all.
So when we call os.exit, you can just assume that from that point on, it's like somebody just walked away and whatever happens, but it's all tumbling down at some point.
Yes. It's a very, very hard exit.
And that's actually the only way you can return an exit code that's non-zero, isn't it?
Right.
So that's interesting then. So you have to be careful with that. You may well want your program to exit with a specific status code, but if you're doing that deep somewhere in your program, it's possible other things aren't happening. So you probably would only want to use OS exit right at the top in the main or very near near there, wouldn't you? Based on probably the return from some other functions that you're creating as part of your application.
Yeah, that's generally a good pattern. Basically what I see is like, you have main, and if you just return cleanly from main, then that's your exit 0. Because actually, interestingly enough, if you look under the hood, when you return from main, all it does is do a very tiny bit of cleanup, which is that race detector stuff. And then it calls the same exit system call. It does exactly the same thing that OS exit does. So that's sort of also just the right point to put the exit, because it's basically like saying, well, if I return from main, it'll just call os.exit 0 effectively. So now is a good point to run os.exit 1. That being said, it depends on the program, right? Like I could certainly imagine a program where you get to a point and you're like, there is no way I can proceed. Even if other things are still running, there's absolutely no way I can proceed. Maybe it just makes sense to drop everything on the floor.
Yeah. And I guess we have panics in Go for situations sometimes like that. Yeah, and that is interesting. Panics themselves are quite an interesting case then here, because they can occur anywhere in the program. And if on caught, they have the effect of ending the program. But defers do run with panics, don't they? We know that because that's how you recover from panics, is you run code in a defer function.
Precisely. Panics are going to run defers, and that's actually not the only thing that's going to run defers. If you do runtime.go exit, like you exit like a goroutine calls runtime.go exit, it will also have its defers executed. And this is, totally safe to do because it's basically just the goroutine itself is synchronously, we know we're stopping execution of the goroutine at this point, and we're sort of walking back and running all of the defers.
Hey Gophers, this episode is brought to you by our friends at LaunchDarkly. Feature management for the modern enterprise, power experimentation in production. Here's how it works. LaunchDarkly enables development and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release, more widely simply update the feature flag, and the changes are made instantaneously by the real-time streaming architecture. Eliminate risk, deliver value. Get started for free today at launchdarkly.com. Again, launchdarkly.com.
So if you're doing like runtime.go exit for a Go routine, I assume that you don't have the same cleanup guarantees that you would have with a os.exit call. Like how you said all the files and all the other stuff from the OS gets handled. I'm assuming that the Go routines files aren't kept track of separately.
No, that's handled at a much lower level, right? So yeah, if your Go routine exits, that says if one Go routine exits, unless it's the last Go routine, of course, then that says nothing about the rest of the resources that the program might be holding on to.
Yeah, that's interesting when you think about things like HTTP response bodies. It's very important, you get a read closer when you get one of these. You get it if you make a request using the HTTP client. You get back a response, and that response may or may not have a body. And we're responsible for closing those bodies to clean up memory and things. Presumably, that gets sorted out for us if the program ends, things like that, because they sort of rely on the underlying operating system for managing resources, right?
Right. So again, in the Unix philosophy of everything is a file, so is an internet connection. So is a TCP/IP connection, which sort of underlies all of HTTP, right? It's the backbone to this. On most operating systems, built right into the operating system. And it's usually exposed through an interface that looks like a socket. And the interface for this in Go looks like a net.con. And that sort of represents the underlying connection. And so basically, if you os.exit, it's going to close that socket like it was any other file. So if you have a client on the other side listening on that connection, then it's going to be the same thing as if the connection was abruptly ended, right? So it's the same sort of failure mode.
The cool thing about some of these is you can actually test them. If you like go write a little program that just has a web server and just sits there and sleeps for 10 seconds and curl into it or whatever just to make a connection and then close the server and see what happens, you can kind of see what's going on.
You mean as a client of a server just dying?
Yeah, like if you just use curl as the client to connect to your server that you just wrote, like running on localhost or whatever, and your server's just like doing like a sleep for 10 seconds before it responds, and you control C it or kill it before it's actually done, you can kind of see, well, did this close the body or respond or anything?
Quite a cool API, that. Just sort of restful mindfulness. Not restful, but mindfulness, sort of just sleeping. Little API to just sleep. I think that's a great idea, especially in today's world of just, everything's fast, going fast outside like in a film.
It's perfect. People call it to see if a web request is timed out.
Yeah, there you go. It's nice. Michael, how did you get into computers in the first place, mate?
That was like a long time ago. I actually started with what is now dead, Flash.
Yeah, oh, really? Flash?
That was sort of my foray into it like a really long time ago. And then it just kind of spiraled from there. I thought I wanted to be an animator. Then it turned out I was terrible at drawing things. And then I kind of dug into the programming aspect. And
ActionScript, wasn't it?
Yeah. And then I dug more into it in high school and college, and now I'm here. Well, several years later, and now I'm here.
Yeah. No, that's cool. Yeah, I used to do Flash as well. ActionScript got quite good as a language, didn't it? It got really quite... I couldn't believe all the things you could do with it at the end. But I agree. And I liked the fact, too, it was very visual. Because for the web, you couldn't do that much with CSS, and you were very limited with stuff. So Flash was the way to get something a bit more interesting in the web back then. Nothing wrong with Flash. Yeah.
Yeah. I have very fond memories of using the actual Flash software itself, not like Flash Player, but just like being able to drag and drop things, and like you click a little object and you put code directly on it, and just feels like, wow, I can put code directly on this button to like have it react to things. And
it sort of makes sense, doesn't it?
Yeah.
I liked the fact in Flash and in ActionScript, you had objects that were like base classes. So you could have other objects that were versions of that in some way transformed. So that was a very strange mindset to get into. But I suppose if you're used to OO programming, it probably fits quite nicely. I remember that being quite cool, where you could make changes to the base object and it would sort of cascade down the entire tree of them as well. Yeah. I don't know if that'll make it into the Go podcast, mate, about Go, but...
So one of the questions that was asked, I believe, on Twitter was, why are deferred functions not run when os.exit is called?
I think there's actually a pretty good explanation here. So if you call go exit, right, then you have a goroutine that's saying, I'm done, right? I'm going to quit. And so it is totally safe for it to run its own defers, right? But now consider, like, you have a goroutine that decides, oh, I'm going to exit, and now let's consider this world where if you call os.exit, it runs all the defers in your application, right? So what ends up happening is the goroutine calls os.exit, and it stops everything else, and it asks all these goroutines wherever they are to start running their defers. The tricky part is it's not always going to be safe to run those defers. You don't know where those goroutines actually stopped. With the go exit, at least you as the programmer know, okay, I'm calling this at a point where I know the defers are going to run fine. So let's say you have a defer that relies on some variable that it captures. Like, you have defer, func, open parentheses, close parentheses, and in there you do something with a variable declared outside that's a pointer, and it's nil at first. But by the end of the function, it is actually non-nil, and it's relying on that to not actually panic inside of the defer. Well, what happens if some other goroutine calls go exit like right in the middle of that function's execution? Now your exit is going to cause this other goroutine somewhere else to panic, and that isn't what you intended at all, right? And it also brings this sort of global thinking into your code where now you have to consider like, oh no, but maybe this can actually be nil because something else can call go os.exit. There is a valid question of whether maybe os.exit should, execute the defers of the calling goroutine, the goroutine that actually called os.exit. But it just seems a little, I guess, inconsistent to do that. It seems a little weird to just have that one go. But I don't actually have a good answer there. That for me could go either way.
I would imagine that one would be weird in the sense that, like, if your defer somehow has like an infinite loop or something in it, which I know sounds weird, but if there was something weird like that, you'd probably want some other way to like finally terminate the program, I guess, programmatically. And, so like you'd need some other API that basically does what OSExit does, but like not being OSExit, and then it would just be weird. And I think one thing worth like clarifying, which I don't know if we've actually touched on, is when you call os.exit, it terminates all Go routines, correct?
Yes.
I was going to say, I don't know if we'd actually touched that, but that was like a big part of what you were saying there was like, if another Go routine gets shut down randomly, it's not the one in control of that.
Yeah. When I think about exit, I think of a Go program as just like this one big black box, and it's almost like you're just throwing that whole box into the garbage, right? That's what I think of when I think of exit, right? And that includes all the Go routines inside, all of the resources that were contained within that box.
Mm-hmm. So it's interesting then. Do you think that's a sensible strategy? If you've got a program that maybe, like John, you never expect them to end because they're that good and people rely on them that much, they can never end. Or if you've got a situation where you've got lots of Go routines, maybe that are going to be running, but when you want something to stop, you're just happy that they all just get aborted and it doesn't matter. Is that an okay strategy? If a junior developer did that, would they receive scorn from senior developers?
I don't think so. I think generally speaking, there aren't that many cases where a truly graceful shutdown is necessary. And especially because in those cases, things get really messy, right? There are some resources that like you really do want to clean up, right? If you have a child process and you say that you want to wait for that child process to end before you exit, right? Or let's say, you're running as root and you create a new network interface because you're Docker or something like that. When you exit, you might want to actually clean that up, and cleaning that up, especially in a large application, no matter what could possibly happen, is actually fairly complicated to do. So my perspective on this tends to be, one way to look at it is have a graceful shutdown, try to clean up everything before you exit. Another way to look at it is just have your program be resilient to stuff being left on the ground. So when it comes back up and it sees that there's something with the same name already there, then it just deals with it in some sane way. It's always going to be hard, right? This is always going to be a hard problem. Cleaning up or tear down or shut down, termination, whatever you want to call it, is always a hard problem.
Mm-hmm. Yeah, but I think that's good advice, though, Michael. Even if your program you're writing doesn't really need to do much graceful shutdown, it's quite nice practice to build that into a little command line tool, for example, where you interrupt the command C, even if there's just printing a statement to say that we're cleaning up or finishing or whatever. I think it is good practice building it in. Dave Cheney talks a lot about when you start a Go routine, know how it's going to end. If you think about long-running systems that have this long life, then it matters. It matters when things are going to get torn down, especially if you're not relying on them to just be restarted all the time. So I think it is quite nice. It's nice to have that as a mindset, and also can help your design too. Like, it might lead you to a slightly more elegant design if it's difficult to see how you're going to stop certain things from running. Maybe there's a simpler way to put it together. But I don't know.
I absolutely agree.
Yeah, subprocesses are interesting. I learned by default when you run a subprocess, it doesn't get terminated when your program gets terminated. At least on a Mac, it didn't. And I had to set the program group, I think. I had to set some group ID. I think there was some workaround. It was a strange thing, though. Do you know anything about what's going on there, Michael?
Yeah, so the way this works is that if a process has children and it exits, basically every operating system, I know Windows has this exact same behavior, and so does Linux, that if a parent process exits, then the child is orphaned. Instead of just being exited immediately, which, there, like you said, there are workarounds with this. You can treat the whole process, you can make a process group and, send a signal to everything in there. But if you don't do that, then the child is orphaned and it has to have some kind of new parent to fit into this sort of hierarchy of processes. And on Linux, that means getting inherited by the root process, which is just this process that sits there and waits for its children to finish up. So if you do exit and you still have a child process running, it will continue to run, until it closes.
Yeah, so that is interesting. That is worth watching out for, because I don't think that's what you'd expect to happen. I feel like if you think of starting up sub-processes, you'd expect them to terminate when the signal is received into the program that started them. But yeah, there are workarounds. One of them is, of course, to use command context and use context again. And that way, when you cancel the context, it has this cascading effect. I think of killing, basically, the sub-processes. That's another way to do it, which is quite cool.
When you do it that way, if you just OS exit, does it end up propagating through all of those as well then?
No, I think OS exit just kills everything gone, doesn't it? So
yeah, if you have Go code that's supposed to run to clean up your sub-processes and you call go exit, there's no guarantee that it's going to run.
Yeah, you'd have to exit through some managed mechanism, usually returning an error or something. Can be different ways to do it. It's just part of the design, I guess, yeah.
And just to make sure I'm on the same page, when you're talking about sub-processes, you mean if you're using I think it's command is the function in Go?
Exec command.
Yeah, exec command, and then you grab the output or whatever from it if you need it.
Well, there's an exec command context as well that takes the context and kills the command if the context gets cancelled. So that's very cool.
I thought that's what you're referring to, but it is interesting that doesn't exit, because I don't know what I would have really expected without reading the docs or hearing you say that, because I've definitely used it before, but I've never thought too much about it, because most of the time I'm running really quick things. But I could definitely see if you were starting up a server, doing something external, that might lead to some weird behavior.
Yeah, well, it just keeps running the processes and you have to go and figure out why.
Also, it should be, I should say it'd be a weird bug where the next time you run and it's this port's taken, you're like, what? Why is it taken?
Actually, that is exactly almost, I think, how it manifests for me. It's always that case. Yeah.
Yeah, it's OS exit is actually if you putting into context, it's really low level when you think about it. Yeah, it's not really. It really does just drop everything on the floor. If you want to sort of clean up a child, and actually I've run into this too, where I'm trying to clean up a child process, and now I have all of these complicated defer statements and using the signal package to capture control C so that I can try to gracefully clean up the sub processes and stuff. Because again, it's a server sitting on a port.
This episode is brought to you by our friends at Equinix Metal, globally interconnected, fully automated bare metal. Equinix Metal gives you hardware at your fingertips with physical infrastructure at software speed. Accelerate your workloads with fully automated bare metal that's secure, powerful, and cost-effective. This is the promise of the cloud delivered on bare metal. Equinix Metal makes it easier than ever to take advantage of the unmatched global reach and connectivity ecosystem made possible by Equinix, which includes more than 220 data centers across 63 metros, making interconnection easy. And they're obsessed with making bare metal even more awesome. Seriously, check out these features. 60-second deploys, hourly pricing, a customer success team that engages over Slack, x86, Intel, AMD, and ARM, single tenant, NVMe and SSD storage, RESTful API, first-class DevOps integrations, Equinix Fabric integration, support for enterprise OSs and open-source Linux OSs, air-gapped installs without a public IP, no installed agent or keys, extensive open-source love and support, plus so much more. Visit info.equinixmetal.com/changelog. Get $500 in free credit to play with, plus a rad t-shirt. Again, info.equinixmetal.com/changelog.
So you said that OS exit's pretty low level. If I recall correctly, in C++, don't you return the status code from main?
That's correct.
I guess what I was going to ask is, what are your thoughts, I guess, around that as to why, Go obviously doesn't do that. So if you were doing that, I assume defers.
It could do that.
It could, I assume.
Func main could return an int. I don't think there's anything wrong with that.
No, it doesn't. Like, I'm kind of curious. Like, my guess as to why it doesn't do that would just be that most people want to return 0 anyway, and it might be confusing to somebody. I know if you're first learning C++, you're like, why am I returning a number here? This, like, who's using it?
Yeah.
But I didn't know, like, when you want to actually have an error status code, the only way to really do it that I'm aware of, at least, is OS exit. And if you're calling that, then things might not behave the way you expected.
Yeah.
Well, yeah, I was going to say, so on that, specifically, like I've done it before where I have special error, like sentinel error types, which is another term coined, I think, by Dave Cheney. These, where you have a variable that is just an error type, or some other way of being able to figure out what the type of error is. And then at the very top in main, I always just call into a run function. And then I, on the response of that, check the error that returned from this run function and check it against any specific values for the specific numbers. Otherwise, I'll just return with some generic one. And that way, you keep all of it in func main. All the OS exits are in one place. And you can kind of logically see the entire flow when it starts to get unwound.
We've talked about that pattern a couple times, and I think until you run into some of the issue, like the bugs, it's hard to understand how many different small bugs it can kind of prevent. Like this, where like if you're doing it that way, all your defers in your run function will run, and everything else will run as you expect it to.
Yeah.
But if you don't realize that, I could quickly see just putting everything in main and calling os.exit and then being confused as to why something didn't defer, like some defer didn't run.
Yeah. I think that's a good point. One of the nice things about not having an int return from func main is that it is kind of simpler. So it is that expected thing, and it looks like other Go code, of course, returning an int would as well. But yeah, it's those run. I love those little run function abstraction things. I do it as well where I pass arguments in. So even if I'm going to parse flags or something, I do that inside the run function, pass in the OS args, because I can test that entire program in test code without any shenanigans, just by calling that run function with different arguments and check the response, So yeah, that one turns out to be a great. And often I'll take a context into that run as well. And that allows me to even test cancellation and timeout and things. I can make sure that if I set a timer in a test for 1 second and I kick off the program, I can check the time difference after to make sure it wasn't too much longer. And then I know that my program is respecting cancellation in context, for example.
So Matt, you talked about graceful shutdown quite a bit. Can you give some examples of like more concrete examples, I guess, of when somebody should be thinking about it?
Yeah, well, times where I've done it, originally in a sort of HTTP context, we wanted to finish any current requests before exiting. That's now built into the HTTP package. I think you can use listen and serve in a specific way to get that. I'll check that and put it in the show notes. Now I need to just write that down because I sometimes have promised show notes and not delivered them, and then I've received quite a stern telling off. Sorry about that. And another time is if I'm processing files and I'm going to be doing some kind of IO copy or some operation like that, where I would rather not interrupt it and leave some weird half file that I don't know what's going to happen with it. It could become self-aware. It could, probably not, but you don't want to take chances. That's how things happen. So yeah, it's things like that. I don't know if it's that big a deal, whether I would let it just be a corrupt file, because maybe I'm deleting all the files when I run this program anyway. But I like the practice of making programs gracefully shut down. And then it's a tool I have in my tool belt that I can just use whenever I need to.
I definitely agree with the practice part is good to keep there so that you're doing things the right way when it actually matters. Because I know, like I said earlier, I'm guilty of not always gracefully shutting down. And one of them is where you said about cleaning up files. If I were to just Control-C a program that was doing something with files, I would just assume all the files are probably not valid, delete them all, and just restart if it was generating files. That's
another strategy, isn't it?
Yeah, I mean, for quick things, it's like, all right, is deleting the files and rerunning the program going to take more time than writing graceful shutdown code? Mm-hmm. So you kind of have to weigh which one makes more sense. But if it's like a one-time program, then sure, whatever. But if it's something you're going to be using a ton in a company, then maybe that doesn't make sense.
Yeah, I think it also depends on the situation as well. Because another time I've used this is when we were going to run code in like Docker. and running in some kind of cloud environment, the interrupts are essentially the platform telling you that this instance is going to be going away. And you may well be in the middle of handling some request, where that could happen. So yeah, that's another time where we've had to just take the signal and don't just deal with it, don't just OS exit, but hold on to that signal, usually in a buffer channel with space for one buffer, at least, so that you don't block there. And then just wait for it, finish the work, and then exit. Don't take on any new work. That's the other thing. You sort of flip some switch to say, no, we're in shutdown mode now, so we won't receive any more traffic. A lot of these problems are probably solved, but I think depending on, like, if you look at the 12-factor or 12-factor application kind of design, using these fundamentals and being consistent like this, it just has benefits, because other systems that are going to be running your code or interacting in some way will also expect this kind of behavior. So there's something to be said as well for being a kind of good citizen in the operating system, I think, as well.
I think the 12-factor stuff is something that definitely plays a big role, because, for anybody unfamiliar, it basically means one of the big things of it is that your server can be shut down pretty much at any time, and you'll lose anything that was on the hard drive or anything like that. So you can't really count on all of those local file systems to be there. And usually there's workarounds around this where you can directly upload files to wherever you want to get them. But I've definitely seen services where you upload a file and then the server will take and process the file or something and upload it somewhere else, like S3 or something like that, or Google's image or blob store. And if you're doing something like that, I could see graceful shutdowning being something that's vital, so that that somebody didn't upload an image and then you don't actually push it where it needs to go, because that would be frustrating for the user to be like, well, the image was uploaded, why isn't it still there?
Yeah.
All right, I think we are ready for unpopular opinion.
Okay, it's that special time again, so gather round, children, with your pints of beer. I've got nieces and nephews, but I don't know what I'm doing. It's time for unpopular opinions.
Unpopular opinion. Unpopular opinion.
Okay, who wants to kick us off? Michael, do you perhaps have an unpopular opinion?
I'm sure I have lots. And I want to preface this one with saying that, my mind is absolutely open to alternatives in the future. This is not a hard and set thing. But my thinking right now is that, and this is maybe going to go a little deep, but I don't think the Go garbage collector needs to become copying or a generational collector. So if you're not familiar with those terms, don't worry about it. But I think going forward, there's enough room to grow here that we can make a really, really, it's already first class and quite good. There's been a lot of excellent work put into it. Mm-hmm. But I think there's so much room to grow here that the common sort of, there are lots of reasons why the common thinking of like, well, of course, generational garbage collection is going to make your programs run faster. I think there's a lot of reasons why that same sort of thing doesn't hold in Go. And I think that there are actually better paths forward going forward. So that's my unpopular opinion. And of course, maybe I'll change my mind in like a year or two, but that's where I am right now. That's where I've been for like a year.
No, that's a great one. Well, we will be testing these on Twitter. We do the poll and find out if they are popular or unpopular. That's going to be an interesting one. John, what do you think? You probably, I suppose you don't use garbage collection because none of your data's garbage or something?
No, I use the garbage collector all the time, Matt.
Ah, okay. What do you think about that opinion?
I am probably in agreement. I don't get worked up about the garbage collector like other people do, though. Like, I don't have any need for it to change or, yes, it's been improved and that's great, but most of the time garbage collection is not a limitation for me, so it's not something I think about is the best way to put it.
Mm-hmm. Is it that, Michael, that it could be in some situations one approach is better than others, depending on the situation?
Absolutely, yeah. The design space for garbage collection is quite large. You have, for general purpose application, it's almost sort of feels like a lot of different languages and runtimes have sort of settled in a particular place. But there are a lot of niche sort of collectors. But I think maybe it's worth exploring that design space for general purpose programs too. And I think Go has some special properties that make it particularly worth looking into.
Yeah. I know somebody who turned off the garbage collection because they had this program that just ran for a short amount of time and would never need that much RAM. And it just ran like kind of lightning fast, so they didn't have the garbage collecting happening at all. Which kind of
How do you turn off the garbage collection?
it's a flag, isn't it, Michael?
Yeah. So Go's garbage collector famously only has one knob, and it's called GoGC. You set it via an environment variable, or you can use the debug.setGC% API runtime/debug.setGC%. And what it does is it lets you make a trade-off between CPU and memory, but you can also just say off. So you either pass it a negative number in the runtime API or in the environment variable. You just write off. GoGC equals off. It won't collect anything. It will just keep allocating memory, even if it's garbage. It won't try to collect it.
So this is the perfect way to make sure my program's eventually shut down.
Yeah. It's funny when you look at memory profiles, you're like, sometimes like because you can look at a memory profile and see like the total amount of memory that your application has allocated. And for like a long running server, you'll see like several terabytes or like petabytes of information, depending on how long it was running, going through there. And it's like, wow, if I didn't have a garbage collector, this would have died a long time ago.
That's funny though, but those numbers are never, you never have any frame of reference for those numbers, really. It's like when they see it on the news, they'll say, in the UK, people have drunk 50 billion cups of tea. And you think, well, is that a lot? I mean, it sounds like a lot, but maybe it's not.
It's like,
Maybe
I
it's
don't know
just
how many people there are there. I got to look that up first.
Exactly. You have to, so it doesn't help, does it, knowing how much RAM you've needed in the lifetime? Although I'd like to see it.
It's useful for finding like memory leaks and stuff for sure.
Yeah.
And other things.
It's good for like infographics if you're going to build one.
What about that idea though of just don't worry about it, turn off garbage collection, rely on that sort of hacky, sounds like a hacky thing, but somebody made the case for doing that in a cloud environment where you just have these little short-running function-like things that just spin up, do their work, and then disappear. Kind of like a Knyszek or some other, I don't know, I can't use that reference, I don't think. What about that as a strategy? Is that just mad?
I don't think it's totally mad. I don't know if you know about, or if the wider Go community know, or probably because, but the Plan 9 C compiler, somewhat famously it just allocated memory and it never freed it. It was written in C and it just called malloc, but it never called free because the assumption was by the time you're done compiling, whatever, the OS will clean it up. It's fine. So for short programs, there is some wisdom here, right? And I've known other systems that have done something similar, right? Because there are performance gains to be had. If you know you're not going to run for a very long time, then of course that, it works. Of course, I will say that like in most cases, probably doesn't make sense, right? It could certainly be like a premature optimization, especially if you have like a command line tool that's growing to do more things. One day it's just going to crash and you won't know why.
Yeah.
But it can be valid in some circumstances.
Very cool. Well, it's that time where I'm cancelling contacts. I'm going around giving you signal interrupts. I'm not going to kill you, but I'm going to be calling OS exit on this episode. Thank you so much, Michael, for joining us. And you'll have to come back and talk about some other things in the future too, if that's all right.
Yeah.
We'll test your unpopular opinion on Twitter. If it's not unpopular, you do have to come back. That is legally binding.
Got it.
John Calhoun, always a pleasure.
Thanks, Matt.
Do you want to say something nice to me?
Right now, I'm the only person who actually has os.exit for Zoom. You guys can't end the meeting for everybody, just for yourself.
Oh, you've got it, yeah. You've got the power of the exit. Yeah, all we can do is call runtime, that runtime one for goroutines. Pathetic.
Zoom doesn't quite work the same way. It doesn't give everybody that permission.
Fair enough. Okay, well, thanks so much, everyone, for joining us. See you next time.
If this is your first time listening to Go Time, subscribe now at gotime.fm or search for Go Time in your favorite podcast app and hit the subscribe button there. You'll find us. And follow us on Twitter if you want in on that free Raspberry Pi 400. We are at GoTimeFM. This episode was hosted by Matt Ryer. It was produced by Jared Santo with music by the Beat Freak, Breakmaster Cylinder. Go Time is brought to you by our awesome sponsors. Special thanks to Fastly, Launch Darkly, and Linode. On the next episode, Daniel Marti returns with some Go language proposals that you've never heard of. That one's hitting your podcast feed next week.
I'm like genuinely not sure how the Terminator would work, given how much like Internet of Things, like all the devices that go offline when AWS goes down.
Yeah.
If you go back in time where there is no AWS,
Yeah.
I'm like, this isn't going to work.
Yeah. But do you think he runs on AWS?
I mean, he's got to be using some sort of cloud stuff.
You'd think it'd be abstract cloud if he needed that. But
If it's anything like our current timeline where we just make everything in the cloud.
yeah, maybe Terminator just got loads of Raspberry Pis running a Kubernetes cluster in his tummy. You know what I mean? Probably. Could be. Robocop's got a gun in his leg. You can just get that whenever
Oh
he
my.
needs it.
I haven't seen those movies in so long. Remember, like I was young and my parents would be like, you aren't allowed to watch this. It's an R-rated movie. But like it was still at the house somehow. It was like the movie they pulled out to test the surround sound system.
Really?
I think so. Because like all the shooting I don't know. It was just... I remember a new surround sound system. I was like really young at the time. And like that was the movie I think they got out to test it and I wasn't allowed to watch it.
Fair enough. Okay, we should maybe start the... remember that podcast we're doing?
Maybe.
What? Wait, sorry, what?
Yeah, we should do that.
Okay. I guess I'm ready for that.